Dear students, we are back to the class of geometric design and we have been discussing about the alignment design. In the case of alignment design, we have so far covered lot many aspects, starting from the factors which governs them, the surveys, then we talked about the horizontal curve, and then we also talked about the skidding and overturning conditions which may happen on a flat or a super elevated section which is being provided on a horizontal curve. And after that, in the previous interaction we talked about how the super elevation can be provided in field. In today's interaction, we are going to talk about the extra widening on the horizontal circular curve. Now, this is another feature which needs to be provided on this horizontal circular curve. Why it is being provided and how it is being provided and how we calculate the value of the extra widening, these are the things which we are going to talk today. So, very first thing is, what is this extra widening? Now, this extra widening can be defined as an increase in the width of the carriageway on the circular section, so that the vehicles can negotiate the circular section smoothly. Now, it means we are saying that at this particular section we are going to have more of the width, and we are talking about when this width, then in this case we need to see that what type of increase we are going to do on this width of the carriageway, which can be equals to W. Now, the reason why we are going to do that is what we are going to talk further, but the point here is that when you are talking about this particular curve and say it is a two lane system where the traffic is moving in both the directions, then on this curve there is going to be a centrifugal force P acting outwards, and depending on the speed with which the traffic is moving, this centrifugal force is going to have its impact, because this P is equals to mv square divided by Rc, where v is the speed with which the vehicles are moving and m is the mass of that vehicle and Rc is the radius of the horizontal circular curve. So, as the speed increases a bit, it has an impact in terms of a square of it on this force which is acting outwards, and that is the reason that we are trying to see that if there is any such movement which happens, if we widen this section, is it going to be helpful to the vehicles which are moving on this, and that is where we are talking about that these vehicles which are moving, they should be able to move smoothly and they should be able to steer the vehicle at the design speed with which we are talking here, that is V. Now, when you are looking at a vehicle, then we have different type of vehicles. We have a very small vehicle like a bicycle, but a big vehicle like a truck, and then within a truck we may also have the multi-axle trucks, and then we also have another combination which is a combination of two units. So, there may be a driving unit along with a trailer unit. So, all of these multiple type of things which are happening on a road creates different scenarios. So, let us see that why we are going to provide this type of an extra widening, which otherwise here also is being shown, as you can see that if I say that this is extra widening. So, if I define it as WE, whereas the carriageway width is being defined as W, then this is what we are going to provide, maybe on one side, maybe on both the sides of this particular carriageway. Now, one thing which is clear from this particular diagram is that we have a value of WE at this point as well as this point, whereas it starts from this and it increases a bit slowly, therefore, WE at this point is 0. So, we have a straight section which can also be defined as a tangent section, and on this tangent section we do not have a requirement of providing this extra widening. So, it is 0, but as soon as we are on a circular curve we need to provide a constant value of WE, and this WE should be attained on the transition curve, and we are going to talk about the transition curve subsequently once we complete the discussion on extra widening. The only thing which you can see here is that WE is changing from 0 to the total value of WE all along the transition curve, so that by the time you have a circular curve, you have already implemented or achieved that extra widening. Now, what are the various reasons, what are the various types of extra widenings which are there is what we are going to talk next. Now, very first thing is, as I said, that we have a different category of vehicles, and if we say that we have a vehicle like this which is going to move in this direction, then it is having an axle here and this is also having an axle here with the wheels, So, you have a front axle and you will also have a rear axle on that particular vehicle. There is another case which can be that this is one unit and then there is another unit being provided and they both are being connected, and again we have the set of wheels being provided here in this form. So, there is a trailer condition also being provided. So, this can be a semi trailer condition, this can be a complete trailer condition, like if you talk about say for an example in rural economy a tractor with a trailer. So, that sort of a situation is also possible. Now, when we are looking at this axle system as a front axle or a rear axle, they are also being connected together by a base, and that is what is we are talking. This is a rigid wheel base which is available. So, the whole of the body is being constructed at the top of it. Now, what happens when this type of a system negotiates a curve? So, when it negotiates a curve, then the front axle wheel is not going to follow the profile of the rear axle wheels due to the rigidity of the wheelbase. So, when we start taking a turn, so I have made a turn like this. So, what is going to happen is that there is a movement in this form, but this movement is going to be a different movement. So, what you found is that there is going to be a change in the profile of the two axles which are moving in the same direction, and this is happening because this system is rigid in nature. Now, if this is the thing which is happening, which cannot be controlled in any form, because this is bound to happen based on that what is the length of the vehicle, what are the widths between the two wheels on the axle and all of those things, we take this into consideration, and then this particular thing is being defined as mechanical widening. Now, apart from this, when we are moving on a curve and we are going say in this direction or we are going in this direction, depending on which particular lane we are, either we are on inner side or we are on outer side of this particular curve. What you will found is that these drivers have a particular psychological condition, and that is what is being talked here in the second point. What it says is that while negotiating the curve, the driver on the outer lanes, they try to keep the vehicle towards the center line to maintain the safety of the vehicle, because this force which is acting outwards, they will try to steer closer to the center line, because if anything wrong happens, at least they have the space. So, if they are closely moving like this, so this much space is available to them so as to maneuver and rectify if something wrong happens. So, they are trying to do that, and those vehicles which are on the inner lane, they tries to move towards the center line to get higher visibility, because once you are near the center line, it means this is the space you are going to get, but once you are very near to this one, then the space may be obstructed by the type of development which may be there on the inner side. So, they want to increase their visibility on the road ahead, and that is what they are trying to move. So, they are trying to move in this direction, outer side vehicle, and this is trying to move towards that particular side, the central line. And if both of the vehicles comes very near to this, then there is a problem of a clearance here, and if this clearance between the two vehicles reduces a lot, then this may culminate into a hazardous situation. So, this is what we are trying to talk here, and that is what if this particular space is being maintained, then for that particular reason whatever the width is required is defined as a psychological widening. So, these are the two type of the widenings which are going to be there: mechanical widening, which is are coming out of the properties or characteristics of a vehicle in terms of its base, and psychological widening in terms of a driving behavior. Now, apart from this, when you are talking about again and again the centrifugal force which is acting in the outward direction, then also there are few things which may happen. Now, let us talk about two other aspects. One is defined as off tracking and another is being defined as skidding. Now, in the case of off tracking, what happens is again we have a rigid wheelbase, and then at the same time there is a trailer combination, as I have shown you in the previous case. So, when you have this type of a situation, what happens is, and you might have seen that on the road also, that if there is a turn being taken, then the driving unit is taking a turn because very easily, because it is being steered and the steering vehicle's wheels are there at that particular point itself. But then the trailer unit, it is not going to follow the path which is being followed by those steering vehicles. So, the trailer will take the path on the inner side, usually when moving at a slow speeds, and this requires extra widening on the inner side of the curve. So, this is another aspect which may happen. And in the case of skidding, what is happening is that when you are moving at a higher speed and you are negotiating a curve, then obviously there is a centrifugal force which is acting, and this centrifugal force is acting outwards, and because of this value of V, which is now compounded as a square in terms of a force, is going to create a jerk towards the outer side. And if you have to control the vehicle so that it remains on the carriageway, we again require widening on the outer side. It means there is a requirement of a widening on the inner side, there is a requirement of the widening on the outer side, and there are two types of widenings which we talked about. One is the mechanical widening, another one is a psychological widening. Now, let us see in this particular case what is happening, that you have one set of axles here, another set of axles on this side. Say if we are talking about, say if this is moving in this direction, then in this particular direction the steering wheels, they are going to follow the carriageway. But if it is a long vehicle, the base is quite long and this base length is being defined as L here, then these wheels are going to be outer side. So, when I am talking about this case and I am saying if this is a front axle or this is a rear axle condition, then the path which is being followed by the wheels is different, and that is where you have this type of a movements towards the outer side. Now, another case which can be there, if I assume it that I am going to move in this one, and in this case my width is this, whereas here in the previous one we talked about this way, then there is an off tracking which is happening when that vehicles are moving at a slower speed. So, when this is happening, so you can say that is a slow speed condition, but when you say that you are going in this direction, it has gone out, then it can be a fast speed condition, and then that is not an off tracking. We can say that a sort of a skidding is a possibility which can be taken place here. Now, when we have to resolve it, when we have to find it out that because of this type of a wheel based condition and extra widening which is going to be there is mechanical in nature, then we are going to use this particular diagram so as to identify that how this extra widening Wm can be calculated. So, extra widening which is because of the mechanical reason is say being defined as Wm. This is another case where what we found is that the rear wheels are going out when the front wheels are within the pavement. So, there is a force which is trying to take them out, and that is where the skidding is happening in this particular direction. If this is happening in this direction, then what you need is again the widening here, and this widening is again we are going to talk about that this is for the skidding condition which is happening, but then culmination is because of the vehicle base which is there. So, when we have all of these types of widenings, then let us look at that how we are going to calculate the value of this extra widening, and then finally how we are going to provide these extra widening in actual. So, not going into the details of how we are going to find out the formula. So, we have extra widening WE which is equals to mechanical extra widening plus psychological extra widening, and this mechanical extra widening, this is being defined by Wm is equals to n L square divided by 2R, where n is the number of lanes. So, if we have a 2 lane system, then n is equals to 2. L is the length of the wheel base which is there. So, total vehicle base which is there, that is being torqued. So, it is usually is around 6 meters, but otherwise if you have the vehicles and you have the average values of those can also be used here. And then R, this R is the radius of the horizontal circular curve in meters. So, these are the values which are there. In the case of psychological extra widening, it is being calculated as Wp is equals to 0.1 into capital V divided by under root of R, where this capital V is the design speed, rest of the thing we have already discussed about. So, that means when you are talking about these two components of Wm and We, then this W e is going to become N L square divided by 2 r plus 0.1 times of V divided by under root of r. So, you have this total extra widening W e we are going to calculate for the given conditions. So, for the given conditions means then we need to know that what are the total number of lanes, what is the radius, what is the design speed, and what is the wheelbase. So, if you have this type of an information available, then you can very easily calculate it. Now, there are few points related to the implementation, that whatever value you have calculated given for the given conditions, now how you are going to put it into the field. The very first thing is that no extra widening is required if the radius of the horizontal circular curve is 300 meters or more. So, this is very first thing. That means, if you have r being given as 400 meters, then we can say that W e can be considered as nil. We are not requiring to provide this. Then, as we said that the extra widening is going to be affected by the number of lanes. So, let us look at the first case, that we have a single lane road which can be like 3 meters wide, 3.75 meters wide usually, that carriageway is being provided. Now, in this case the mechanical widening only is provided. So, that means what we are saying is W e is equals to W m. We are not considering W p. Now, why we are not considering W p? So, we have a carriageway which is 3 to 3.75 meters wide. So, this is the carriageway which is this width, and it is being provided with the shoulder on either of the sides. So, usually say if we talk about the single lane road, and this shoulder at the minimum level has to be say 1 meter. So, you have a shoulder here and a shoulder here, and say we assume this is 1 meter and this is 3.75 meters carriageway. So, it becomes 5.75 meters. Now, if there is a vehicle which is coming, most of the time the vehicle will be moving like this, and these vehicles, when we talk about the design vehicle, they have a width of roughly around 2.44 meters. So, when it is 2.44 meters and the two vehicles are coming side by side, then on the carriageway you do not have that much space. So, what you require is 2.44 say into 2. So, it becomes 4.88 meters, and then if there is a gap between the two vehicles, then it is going to be probably more. So, now what we are looking at is when it is more than 3.75, because the two vehicles, so what will happen is the vehicles are going to move in this form. So, they are going to maintain some space here, which is a sort of a buffer space or a clearance, but at the same time this outer wheel is going to take location on the shoulder. So, without this, these two vehicles they cannot cross each other. So, that is a problem. So, once this is happening, it means the drivers have by self they have taken a decision and they have maintained a clearance between the vehicles, and they have just passed each other by utilizing the shoulder being provided on either side of the carriageway, and that is where the psychological widening is not being talked here. We are simply talking about the mechanical widening, and this is what is being talked in these lines. Then if you have a road which is having 2 or more lanes, then how we are going to talk about? So, full extra widening need to be provided to maintain the lateral clearance between the vehicles on the curves. So, that means the total value of W e is to be provided. When we are talking about a multi-lane system, so in the case of multi-lane system, how we calculate this value of W e is what being defined here. What it says is that it is nothing but the number of lanes multiplied by the W e for a 2-lane road, and half of it is what we are going to provide for a multi-lane system. So, that is the way we are going to calculate the values. Now, in the case of 2-lane, 4-lane or 6-lane highways, based on the radius of the curve, the values are already being given. So, we can utilize these values, and what it says is that If it is 75 to 100 meters, then the extra widening can be provided as 0.9 meters, and if it is 101 to 300 meters, then it can be provided as 0.6 meters. In the case of other category of roads or highways, again it is dependent on the radius of curve. So, what you can see is there is a big range being defined here. So, we are going to less than 20 meters and going up to 300 meters, and above 300 meters as we are not going to provide it. So, that is the point which we have already mentioned. So, you have up to 20 meters for a 2 lane system, it is 1.5, up to 40 meters it remains 1.5, then up to 60 meters reduces to 1.2, then for 100 meters reduces to 0.9, and then 300 meters reduces to 0.6. Whereas, in the case of a single lane system, so for a single lane system it is like 0.9 up to 20 meters, 0.6 up to 40 meters, and remains 0.6 up to 60 meters, and after that it becomes nil. So, these are the values which we are going to provide. Now, when we are providing this extra widening, and as we have seen in the previous one diagram that it is provided all along the transition curve, then this has not to be provided all of a sudden, it has to be done at a uniform rate all along the length of the transition curve. So, the full extra widening is made available at the start of the horizontal circle curve. As I said, it starts with W e is equals to 0 at the start of the transition curve, and it becomes W e is equals to W e at the point of a circular curve. So, that is how the transition is going to be there, and whatever is uniform rate which is acceptable, which is comfortable, on the basis of that this particular length is going to be found out. So, the length of transition curve, now this becomes one of the criteria to do that, and when we will take up the transition curve we will see that how we are calculating the length based on all of these criteria. So, here in this diagram it is very clearly being shown. What you found is you have a straight section. So, at this straight section W e is equals to 0, then we are on a transition curve, and on this transition curve the extra widening is being provided at a uniform rate, and it becomes W e at the start of the circular curve, then it remains W e all along the circular curve. At the end of the circular curve again it is W e, and then it starts reducing and becomes 0 at the end of the transition curve, which is provided on the other side of this section. And the width of the carriageway is W, therefore, at a circular section the width of the carriageway is going to be W plus W e. So, this is the total width which is there, which is W plus W e. So, we are going to consider this W plus W e again when we are going to talk about the lengths related to the transition curve. Now, in case the transition curve is not being provided, then how we are going to implement it? So, what we do is that as we have talked about the super elevation. So, in this case also we are going to provide 2/3 of the extra widening at on the straight section, and this of course has always to be done at a uniform rate, and that is the same value which we use in the case of super elevation, and remaining 1/3 is being provided on the circular curve. So, this is how we are going to proceed, and in such cases the extra widening shall be provided in full on the inner side of the curve. So, if we do not have the transition curve with the, in that case the first criteria is 2 by 3 plus 1 by 3. So, transition curve and circular curve, and another thing is on inner side. So, that is how we are going to implement it. Under the normal road conditions, the extra widening shall be done equally on both sides, that is on inner side as well as on the outer side of the carriageway, and this is what we have seen when we talked about the skidding, when we talked about the off tracking. In the case of off tracking we were requiring a width on the inner side, in the case of skidding we were requiring a width on the outer side. In the case of hilly sections, what we are going to do is that we are going to provide it, it shall be done on the hillside rather than on the valley side, due to the psychological reason of the vehicles trying to remain towards the hillside rather than the valley side. And the reason is clear. When you are moving on this type of a system where you have a valley here and then the hill is on the other side, then every time all of the vehicles will try to remain towards the hill, and even the vehicles which are coming from this side, they will also try to maintain a bigger gap on this. So, we need to provide a more clearance here, so that this type of behavior can be accommodated. So, in that case what will happen? So, if we do not have a transition curve, or if we are in a hilly region, then whole of the extra widening is being provided here. So, what you can see is that this is total WE is being provided here, and then it remains constant all across the length of the circular curve, and finally again reduces and becomes 0 at the end of the transition curve. Now, let us look at some of the examples here. The very first example says that we have a 2-lane road. So, when we say it is a 2-lane road, it means n is equals to 2, and traffic is moving at a speed of 100 kilometers per hour. So, we are talking about capital V. The wheelbase of the design vehicle is 6 meters. So, we are talking about L, and the radius of the circular curve, horizontal circular curve, is 100 meters. So, we are talking about R or RC. Now, when we talk about a 2-lane road, that means the extra widening is going to be a summation of Wm plus Wp. Both mechanical and the psychological extra widening are going to be considered. And when we consider those, then the equation is nothing but NL square divided by 2R plus 0.1 V divided by under root of R. Now, when you input the values here, then what we are going to get is we get 1.36 meters. So, this 1.36 meters on this 2-lane road is to be provided on inner as well as outer side of the carriageway. This is another example, and in this example we have a single lane road. So, there is a change. So, n is equals to 1, it is having a width of 3.75 meters and the shoulders of 1.5 meters on either side of the carriageway. That means the vehicles have a possibility of using these shoulders if so required. They are moving at a speed of 40 kilometers per hour. So, capital V is 40 kilometers per hour, the radius is 60 meters, the length of the wheelbase is 5 meters. We have to calculate the extra widening. Now, when we are talking about this single lane road, then the extra widening WE is nothing but Wm, and therefore, the equation which we are going to consider here is NL square divided by 2R, and this NL square divided by 2R, when you put the values, what we get is 0.208 meters. So, this is the extra widening which we are going to use in the case of single lane road. This is another example where we are talking about a 4-lane undivided carriageway. Now, in the case of 4-lane undivided carriageway, the traffic is moving at a speed of 60 kilometers per hour. So, you have n is equals to 4 and capital V is 60 kilometers per hour. The circular curve of radius 150 meters. So, R capital is 150 meters. The length of the wheelbase is 6.1 meters. We have to calculate the extra widening for this road. Now, if you remember when we talked about the multi-lane system, so in the case of multi-lane, it is nothing but n, which is the number of lanes, multiplied by WE for a 2-lane system, and take half of that, and it is being multiplied with the number of lanes, which is going to give you the total extra widening to be provided here. So, when we go with this one, we have to first of all calculate the extra widening for a 2-lane road, which is nothing but a composition of Wm and Wp, and when we put the input values here, what we are going to get is 0.614 meters. So, for a 4-lane system, it is half of 0.614 multiplied by the number of lanes. So, it is 1.228 meters is the value which we are going to provide. So, this is how the extra widening is being introduced, and it is being calculated as well as being implemented on a curved section along with the transition which is being provided just before the curved section on either side of it. So, with this we close our interaction today. We are going to talk about the next element, which is transition curve in the next interaction. Till then, thank you and bye.